Hi, welcome back. So this time we're gonna have an example regarding the combined functions of sine and cosine using or under the type 2. We can say that it is under type 2 if the m and n, the power of this both sine and cosine here, are both they are both positive even integers. So okay, for example, we have sine squared x cosine squared x dx, and from here let's check if they are both positive integers. So the m is positive even and n is positive even, so they are under type 2, wherein we can use this identity or we can use these facts in our trigonometry. Okay, so from here let us now analyze if what identity can we adopt from here. So maybe we can use this one, but let us to simplify this further, or we can transform this further. So we can write this as sine x cosine x raised to 2, right? Then d of x. So from here we can say that this whole term here is just equal to 1/2 sine 2 of x. So we can simply use this, wherein where sine x cosine x is equal to 1/2 sine 2u. So using this we can now transform this as 1/2 sine 2, this is x, 2x, then this whole term here is squared dx. And what else? So simplifying this further, we have 1/2 squared, we have 1/4, and then integral of sine 2x squared d of x. Okay, so from here you should notice how can we integrate this sine 2x squared dx here. So from our type 2 here, let us scan once more on our identity. So as you can see, maybe we can use this form. So let us rewrite or transform once again our integrand using this term. So this is also equal to sine squared 2x d of x. So maybe we can now let change variable x to u. So we let u is equal to 2x, and then after that we can now simplify this as therefore sine 2u, wherein it is equal to 1/2 1 minus cosine 2u, and bringing back the value of u, it is also equal to 1/2 1 minus cosine 2x, or simply or simply it is equal to 1/2 times 1 minus cosine 4x. Okay, then bringing back to the main equation, so we have 1/4. The integral of this whole term here is this. I mean the equivalent trigonometric identity of this whole term here is this one. So we have 1/2 times 1 minus cosine 4x d of x. Then simplifying it further, we have 1/4 integral of 1/2 dx, then minus the integral of 1/2 cosine 4x dx. Okay, so this time we can now easily integrate both terms or both functions. So we have 1/4 multiplied by the integral of this, and the integral of one constant is just this one, minus 1/2 the integral of cosine 4x dx is just let u once again is equal to 4x, then du is equal to 4 dx, but we only need dx here, so let's divide this by 4. Therefore we have du is equal to dx. Therefore we can simplify this as the integral of cosine u du all over 4. Okay, so from here you can now rewrite this as 1/2 x minus 1/2 times 4 is just 8. Then the integral of cosine u is cosine, the integral of cosine is sine. So we have sine u, then plus c. But we need to bring back the value of u, which is equal to 4x. So we have this is equal to 4x. So we can now distribute the 1/4. Then 1/4 times 1/2, we have 1/8x minus 1/4 times 1/8, we have 1/4 times 8 is 32. Then sine 4x. Then of course do not forget our plus c here. This is now our final answer. Okay, so once again let us review. Say we have a combined functions of sine and cosine. So we have sine squared x, cosine squared x dx, and we analyzed that they are both power or exponent is positive even integer. So we classify this as type 2, and by having this type we can now use this identity. So As simplifying this further, we can say that sine x cosine x squared is just equal to this 1/2 sine to u. Okay, so by using this identity, we come up with this form: 1/2 sine 2x squared d of x. Okay. Okay. Then after that, we transform this so that we can now use another identity or use another facts in our trigonometry, which is sine squared with some function of u. Right, in here our u is equal to 2x. So if we let u is equal to 2x, then sine squared u is equal to 1/2 minus sine 1 minus cosine 2u, and bringing back the value of 2u, this equal to 2x. Therefore we have to multiply this 2 times 2x here and having cosine 4x. Then we substitute, or we distribute 1/2 1 by 1 and dx 1 by 1 to this term. Then we come up with the 1/2 dx minus 1/2 cosine 4x dx, and we let u equal to 4x dx. Then the derivative of this is just 4 dx, and we divide both sides by 4 because we only need the term dx. That's why the dx is equal to du over 4. And by using this and simplifying all of this, we integrate this one. So come up with the integral of dx is just simply x multiplied by some constant minus 1/2 times the integral of this, which is equal to 1/8 sine 4x. And then we simplify this by distributing 1/4 to each term, and then we add the integral constant c.